Okay, so we are going to talk about tangent lines in this section. When I am referring to a tangent line, it's a line that touches the curve, okay? Not intersecting like go through, like touch it and bounce off. So for instance, if I had something like this, a tangent line right here would hit my graph right at that point and then bounce off. Now if I had a tangent line down here, it would look like that. It's just touching the graph at that point. So the tangent line has the same direction as the curve. Would you guys agree? Like right here, my curve is going up. My tangent line has positive slope. If I drew one right here, what would it look like? Yeah, okay. This would turn flat, and then here my tangent line would start being decreasing because my curve is going down. So the tangent line shows the direction of the curve itself.
Why did you catch him? You could just let him fall back. You could just let him fall. Okay, let him. You gotta pull him back further. Yes.
You're about to have a spot. You have a heart attack right there?
Yeah, I'm going back to the chair.
Okay. So we have an idea of what a tangent line is. The next slide I just drew one. Now I said it intersects your curve at one spot. It is possible that later on it might hit the curve again just because curves change direction, but we're just saying in the immediate area here, it hits it once. It doesn't like go through the curve and hit it twice in a row right there. Okay. Now, tangent lines are actually huge in calculus. They have a lot of applications. So we are going to be talking about this idea of a tangent line for the rest of the semester. And we are going to talk about all the different things this tangent line can show us. We're going to start by trying to find equations for these tangent lines. So let's look at an example. I want the equation of the tangent line to the parabola y equals x squared at the point 1, 1. Okay, so I could draw myself a little picture. I can draw a parabola. I can plot some points on my parabola. And then draw my curve not going through those points. Okay, and so if I drew the tangent line at this point, all I really know is it touches the graph at that spot. Is it going to have a positive or a negative slope? Positive. Do I know what that slope is? No. Can you find the slope of a line when all you have is a single point? No. So here's an issue. I want to get that equation of the line, but I don't have enough information. If you remember back from Algebra 1 and Algebra 2, to write the equation of a line, you need either a point and a slope, or 2 points. And all I have is a single point. So what we are going to do is, let's take another point. So let's say I took a point close to this one. Okay, you could draw the line going through those 2 points. Couldn't you? Now, that's not an exact tangent line. I'm going to call that point Q for a minute. So point P was the original one. This isn't the tangent line, but you could give me the equation for that black line I just drew if I knew the point on the parabola that I just chose. So if I wanted to find the slope between points P and Q, how do you find the slope? Okay, so I'm just going to call point Q x, y for a minute. So if I were going to find my slope, I would have y minus 1 over x minus 1. But let's say I don't want a y in my problem. Do I know what y is equal to? Y is equal to x squared. So could I change this y to an x squared even? If I didn't know x's and y's. So I have an equation for finding slope. Still not my exact point, but I'm getting closer. Alright, did I give you guys a blank slide after?
Yeah.
Good. Okay, I'm going to make a table here. Alright. Let's say I start at an x value of 2. Then, if my point were 2 for my q, we could calculate our slope really easily. 2 squared minus 1 over 2 minus 1, and we get a slope of 3. But that's still kind of a ways off of my true tangent line, isn't it? What would I need to do to make this closer to my real tangent line? What kind of x's should I pick? Okay. Things getting closer to 1, right? I put in my slope equation here. I'll put it in 2.
Wait, just before you say 1 Q,
Mm-hmm.
you have 1 minus 1 x plus 1.
Mm-hmm.
What is that?
That was our slope formula for an ordered pair x, y. y2 minus y1 over x2 minus x1. I was just trying to shortcut it instead of for every x value I pick having to calculate the slope. I was just trying to get an equation just to save myself a little time. Okay, would you guys agree that if my x was closer to 1, where point P was, would this line look more like my true tangent line? Okay, and the closer we get, the better it would be, right? So 1.1, that's pretty close to 1. Let's calculate the slope. So here's where your calculator's going to come in. Make sure you use parentheses, and we can just type this whole thing in. So I'd have 1.1 squared minus 1, parentheses, over 1.1 minus 1. And what do you get for your slope that time? 2.1? Is that the closest you could get? No, what if I did 1.01? Would that be better? Okay, let's try that one. So if I changed it to 1.01. Then what do you get? 2.01. So is that the closest I could get? No, what if I did 1.001? Yes, we can. Okay, so if you put this one in, you get 2.001. Now, we could play this game all day, couldn't we? No matter what number you spit out, I could get closer to 1. And would you guys agree that as these x's are getting closer to 1, my slopes are getting closer to the real slope of that pink line? So these numbers are getting close to 1. Can you tell what my slopes are getting close to? Looks like 2. Okay, let's try it from the other direction. I did all this with x values that were bigger than 1. But I could also come the other way. I could go things smaller than 1. Like I could maybe start at 0. If you put in a 0 there, what do you get? 1. Okay, but if I want to get closer to 1, maybe I went 0.9. So I'm putting in things closer to 1 that are smaller. So I'm going to end up approaching 1 from both directions. So if you put in 0.9, we get 1.9. All right, but we could get closer. Let's try a few more. So you three over here, you put in 0.99, and this half the room, you guys put in 0.999, and see what you get for your slopes. So here, my x's were getting close to 1 again, and my y's were my slopes were they still getting close to 2? This is actually what is called a limit. We could say, based on this, it looks like my slope of that peak line should be 2. Now, can I say that with 100% certainty? No room for doubt. No, for all I know, it could be 2.0000001. Okay, there could be. There's a little room for error here. So this isn't exact, but it gave me a pretty good idea what my slope is. So now I think I know that my slope is 2, and we had that point that I originally gave you of 1, 1. Is that enough to write the equation of y? Yeah, y equals mx plus b. That appears to be the equation of my tangent line at the point 1, 1. Okay? All of that work was to estimate our slope so we could write the equation of our tangent line. What questions do you have?
So we drew the first line, but then we did the second line. Why did you draw the second line?
Because the first line I drew, I only had 1 point on it. So that black line is kind of like my 1 getting closer to it. So
Could you draw that black line?
you want to be essentially in that area. So I'm not the greatest artist, so you guys have to bear with me here. So the line I want is this one right here. The problem is I only have 1 point on it. So what I'm doing is using that 1 point and another point to write an equation between those. So I wrote the equation of this red line, or found the slope of that red line. And then we said, well, we could even get closer. So maybe I'm going to pick a point on my parabola that's a little bit closer. And then we estimate the slope of that one. And the idea is, as these keep getting closer together, your line is getting closer to that black line.
So each axis, like, we're trying to get closer to that black line.
Exactly. Does that make a little more sense? Okay. So what we're really doing here, we're estimating these tangent lines, but we're really doing secant lines to get there. A secant line goes through 2 points on the graph, so we're trying to take those lines and get them closer to the one we want. So let's define that. A secant line is a line that intersects the curve more than once. So my tangent line hits it 1 time. my secant line hits it twice. So we're trying to get 2 points really close together that would estimate my tangent line. Okay. So the next few slides are really just more describing what just happened there. We say the slope of the tangent line is the limit. You are going to see me talking about limits a lot. So this is just the first time we're seeing that term, but definitely not the last. It's the limit of the slopes of our secant lines. Okay, how I would write that. In my last problem was my limit as x approached, what number was my x getting close to? 1 of my slope, which this was the equation we had for slope. And what did we find out that equaled? 2. Okay, what this says is the limit as x approaches 1 of this expression is 2. Meaning, as your x values get really close to 1, your y value of that expression is getting close to 2. And that was the equation for our slope. This is just a picture kind of describing what I was trying to do up here with my picture. So it shows you this, I know yours isn't color coded, but this pink line here is what I want, and the blue one was the one we were actually calculating. And so what we did is we just made our Q get closer and closer to our P, and we saw as we did that those two lines got closer to each other. I always have people ask, why do I have to do so many points? Why didn't I just plug in 1.01 or 1.001 at the very beginning and say it was close to that? And the reason is because sometimes there are different patterns, and if you only test 1 or 2 numbers, you don't see patterns. So I always want you to do several. I usually say a minimum of 3 bigger and 3 smaller that I want you to plug in. That way you can make sure that there's nothing else going on. Let's go ahead and do this one. So a cardiac monitor is used to measure the heart rate of a patient after surgery. It compiles the number of heartbeats after T minutes. When the data in the table are graphed, the slope of the tangent line represents the heart rate in beats per minute. The monitor estimates this value by calculating the slope of the secant line. Use the data to estimate the patient's heart rate after 42 minutes, using the secant line between the points of the given values of t. Alright, so I am just trying to estimate our heart rate at a given point in time at 42. You notice that the table tells me how many heartbeats at that point, but it doesn't give me the rate, so that's what we're trying to find. I have already told you which t values I want you to find. So essentially all I'm asking you to do is find the slope. Okay? If these are my 2 t's, those are like my x's. So how do you find slope? Okay. So at 42, my y would be 2948 minus y1 would be 2530 over x of 2, which is 42, minus x of 1, which is 36. Why don't you just plug all of that in your calculator at once? Use parentheses, top and bottom. 69.67. Okay, so then I'm asking you to do the same thing with 3 other points. So, how about you 3 do the 38 to 42, and 3 girls do 40 to 42, and then you 4 do 42. Okay, C. 71. D. 66. Okay. Is this one where you can clearly tell what it's getting close to? You know, we're trying to get closer to 42. These 3, I was all comparing something smaller than 42. So I went 36, 38, 40. So is there a clear pattern what it's going to in this one? No, it went up, it went back down. This is significantly lower. So this one I can't definitively say the heart rate is 70. Okay, but we could give a range. So my only conclusion would be the heart rate is probably between, 66 and 71 beats per minute. So it's not always obvious. That's why just picking 1 or 2 points is not enough. We usually need more than that. All right. Questions there? Okay. The next example is probably going to take me a little bit, so I'm going to stop there, but I want to talk about something first.
On the last one, what was that goal?
We were just trying to estimate the heart rate at a given point. So basically the slope at 42. But you have to have 2 points per slope, so that's why we were taking those others and trying to calculate it. Your assignment for this section is twofold. There are a couple book problems and then a handout posted on Classroom. So on the book, we're going to do page 86. Problems 1, 5, and 6. And then the classroom handout. Tomorrow, I will finish this up. It's going to take me probably at least half the class finish notes. So you're not going to have a huge work day tomorrow. We will be going through things most of the time. But I wanted to kind of talk about what you needed to be doing on the handout. I would start there. So if you could, pull out your Chromebooks and go to Classroom. So what this has, we look at the first section. You are going to approximate the slope of the tangent line. So that is exactly like the first problem that we did. When I ask for the slopes of the tangent line, I'm going to kind of set you up on this first problem here. So it gives you an equation, then it's got this and it says 1. That is the x value that you're supposed to be getting close to. Right, so when you make your table, what kind of x's would you need to pick? three things close to 1. We're going to make 2 tables. One with numbers bigger than 1 with numbers smaller than 1. And then you be getting closer. So bigger than 1, you can do like 1.1, 1.01, 1.001. And then want a minimum of 3 points bigger and 3 smaller. What would my 3 points smaller than 1 be? Okay. Since this one isn't just linear, the slope is probably not as obvious. But what you could do is maybe make a y column. And then maybe a slope column. That'll just help you organize your information a little bit better. I could plug this in and get a y value, right? Then you're going to have to calculate the slope between this point that you just found and the point up here. When x is 1, what would the y value be? You put a 1 in. Yeah, do 2 minus 2 is 0. So 1, 0. And then if I put in like 1.1. I get 0.42. So then I'm going to calculate the slope between them. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, and your ultimate goal is that hopefully these slopes are going to be getting close to some number. And hopefully it's the same number in both of your tables. And if so, that number is the answer to your question. Okay? It takes a little bit. We are into calculus now. So where the first day, you're kind of looking at me with glazed over eyes, thinking I don't really know what you're talking about, but I promise it gets better as it goes on. So just bear with me. For tonight, just try the first couple in here.